When trying to use the default character class in Unreal, you're locked in the relationship between the character and the character movement component. It goes both ways and there's not really much you can do about it. That and the fact that most of the character movement component's mysteries are tucked away within roughly 14,000 lines of code. So our goal is to create a basic custom movement component ourselves, focusing on walking, sliding along surfaces, slopes, and stairs. This way you have complete control over your character's movement. Now you might be asking, why would I do this?
I don't know.
We'll do this by referencing how the CMC already handles these things pretty closely. Heads up though, this is C++, not Blueprints. The movement math needs to run close to every frame, so you really want this in code. It's easier than you might think, I promise. Alright, let's begin by creating a pawn blueprint class in Unreal. Our movement component will be a blueprint spawnable component, so we will be able to add it to any pawn we want. Just be sure to give the pawn a capsule component, drag it up here so that it becomes the root component, and then set up the collision info. Setting it to pawn is recommended. If your pawn is ready, then go up to Tools, New C++ class. From this window, you're going to pick the pawn movement component as your base, just like the character movement component does. You'll find it in the all classes thing. You could just base it on the U movement component instead, but you'd have to configure some of the movement input code yourself. Whenever you're ready, hit create and Unreal will set your project up. From here, I would actually close Unreal. Unreal doesn't really like it when you try to change the header files or any of the class properties live. So for now, just keep it closed. Alright, let's paste in some properties here and then move up to the U class line. Inside the parentheses, add a meta equals open close parentheses. And you're going to have to add blueprint spawnable component in it. And if you want, you could also add display name equals whatever. Basically, this just makes it so that you can actually spawn these components in blueprints or in your content browser within the editor. Otherwise, you'll only be able to access components that were added via C++ only. Almost exactly how the CMC is. Also, please don't forget to override begin play and tick component. Without them, we won't be able to cache the capsule component from the pawn, and we won't actually be able to update the component at all. So kind of defeats the purpose. Cool. We're going to test everything before we continue. Back in Unreal, open up your new pawn class and go over to your component list. You should be able to search and see your custom movement component in the list. If so, add it. If not, when you're done adding your component, go ahead and set up your event graph with your input events like you normally would. The setup is done. Now we're going into the weeds of the video. So in order to walk,
You must learn to crawl!
you need to know where the floor is, move along that floor without launching off ramps or getting stuck, and dealing with elevation changes like stairs or steps. We're going to solve them relatively closely to how the CMC does. First, we'll keep our floor info in a struct. I'm calling it F custom floor result. You can name it anything you want. Just remember that structs in Unreal C++ need to start with F as their first letter. This is just going to store a couple flags and numbers. Did we hit anything? Is it walkable? Did we find it from a line trace? How far the floor is? And the hit result itself. We must make sure we go through and define the set from sweep and the set from line trace methods from within the struct. Otherwise, we'll just get compile errors, and realistically, those methods don't do anything if we don't actually define what they do. So we hold on to one of these as a property called current floor. Is walkable is a method that pretty much everything leans on. It's really just checking to see if the surface is flat enough for the pawn to stand on. It compares the hit normal's Z against the threshold. The default is about 0.71, which is roughly a 45-ish degree slope. Anything steeper than that is not walkable. Our sweep, our line trace, and our slope limit all ask the exact same question. Now actually finding the floor. This is also one method, and it's simpler than what the CMC does. We sweep the capsule straight down as far as our max step height value, about 45 units. If that sweep lands on walkable ground, then that's our floor.
But what if the sweep gets it wrong and feeds us a normal that's sideways, for example?
That's where the line trace comes in. If the sweep didn't hand us clean, walkable floor, we send a line trace straight down from the center of the capsule. If it finds the real floor underneath, then that's our new floor. But we never actually rest on the floor. We hover a tiny little bit above it so that the full-size sweep always has a little bit of room and never starts buried inside the floor. That's handled here. Adjust floor height. After we move and we're still on walkable floor, we nudge the capsule to sit within a tiny band between 1.9 and 2.4 units above the ground, and we recenter it every frame. It's basically like a mini car suspension. Cool. So we have the floor logic in place, but it does nothing if we can't move. Calculate velocity is pretty simple. If you're feeding it input, we accelerate in that direction and clamp it to a max walk speed. If you're not giving it input, we decelerate down to 0. Pretty similarly to how the CMC itself does it, minus the friction stuff. For the input itself, we need to use consume input vector. This is one of those built-in functions pawn movement component hands us. Now we know where and how fast to move. So these following two engine functions will do the heavy lifting for us, both a part of the movement component family. First, the safe move updated component. It sweeps the capsule through our delta, stops at the first thing it hits, and hands us back the hit result. Second is slide along surface. When we bump into something, our velocity would just die and it would cause us to get stuck. So instead of dead stopping, it takes the leftover motion and slides it along the surface, allowing the character to skim along the wall instead of gluing onto it. With this knowledge, here's the flow inside move along floor. Take our move, run safe move updated component.
If we hit something in front of us, we check to see if it's low enough to step up, and if not, we slide along that surface. Compute ground movement delta takes your move and without touching the horizontal parts, solves the vertical aspect of it so you can ride along the surface that you're currently walking on.
Now time for the big boy. Step up is a 3-part sweep. Go up by our step height, then forward, and then back down onto the step. We do all three as a deferred move, so if anything fails, like if the step's too tall or what we would land on is too steep, we just revert the whole thing like it never happened. So we only commit if we actually end up on walkable ground.
Steps down are almost free. Find floor is already sweeping down our max step height. Once it finds floor underneath the pawn, adjust floor height, sits them on top of it.
One last thing, and it's just the scope of the video, not really a bug. Since we don't have gravity and no falling state, we can't actually walk off ledges correctly, or at least we get stuck to most of them. It doesn't fall because falling isn't hooked up yet. And there it is. We find the floor with a sweep and a backup line trace, build the velocity, hover just above it, move along it with safe move and slide, ride ramps, and step up and down stairs. This works on any pawn class with the capsule collider as the root component. And I think that's a perfect place for me to end it for now because falling is the next video, so just know that the ledge is going to freeze you in midair until we build gravity. I know it's a little annoying to stop here, but in the next video we'll have to cover states or a way to switch between ground logic and air logic, and I don't want to make this any more complicated than it needs to be, so just be ready for that one.
I know I didn't do a super deep dive on some of the methods in here, and I kind of glossed over them, simply because there's just a lot of information to cover, and this video is taking a lot longer to make than I would like. So yeah, just let me know in the comments below if you guys really want like a 1.5 video that's specifically for these methods, like find floor or step up. Let me know. I appreciate you guys for watching and sticking with me here. I'll see you guys in the next one. Later. Also, sorry for the audio.